Hello.
Casi import recurring portal. Recurring portal.
No. Good morning, James. Sir.
Recording portal.
Yes, sir.
Sir, ஆரம்பிச்சலாமா சார்?
Start பண்ணுங்க sir. Please start. So, am I audible, right?
Yes, yes.
Yes, audible. Okay, perfect. So, good morning to all of you. My name is.
Hello, Pravi sir.
Yes.
First, I would like to say welcome.
Yeah,
After that,
thank you so much.
principal sir, felicitation. Then we start a session.
Sure. I'll be waiting.
Okay, good morning to one and all present over here. With the blessings of our founder, Udyograthan J. Sudhandan sir, it is my pleasure to welcome our beloved correspondent madam, Bharati Sramani, Dr. Vasudha Sudhandan, who is the heartfelt of every activities in our institution. I welcome you, ma'am. Next, I would like to welcome our advisor, Mr. M.D. Devesamani sir, for his kind support. And then I would like to welcome our today's distinguished alumni, Mr. Anup Ravi, for spend his valuable time in this greatest occasion. I welcome you, Anup Ravi, sir. Next, I would like to welcome our respected principal, Dr. M. Ramesh sir, who always consistently support to conduct this type of activities in our institution. I welcome you, sir. Next, I would like to welcome our faculty members and students for this only workshop. Once again, I welcome you all. Next, our principal review school. With the blessings of our founder, our today's program is based also our distinguished alumni, Ravi Krishna Pillai, maintenance lead engineer, Algam International Site, our college well-wisher, Sri Sundaramani sir, Sri Jewelers Hero, Dr. Vettivel, Professor and Head, Department of Mechanical Engineering, Dr. D. Sababari, Professor and Head, Department of Electrical and Electronics Engineering, faculty members, and my dear students, good morning to all of you. First of all, I express my sincere gratitude to Mr. Anup, who accepted our invitation to deliver a lecture on the topic of industrial application of gas turbine and power generation in future. First of all, I thank Anup to accept our invitation immediately. In spite of your busy schedule, you accept our invitation. Thank you, Anup.
Thank you, sir.
Students, yes. Students, as you know, then India is the second largest populated country in the world. Our country is a world's fourth largest consumer of electricity. We are the world's third largest renewable energy producer, like the solar energy, the wind energy, hydro energy, it's like that. In our Tamil Nadu, it's having the different types of power plant, like a coal-fired power plant. It's situated in the Neyveli Lignite Corporation, Neyveli. And diesel power plant, it's located at Ennur in Chennai. Then hydro power plant at Kunda in Nilgiris and Mettur also. Then nuclear power plant in Kudangulam and Kalpaka. It's a various power plant available in Tamil Nadu. But in all over India, still now the power crises are going on with the summer time. So then we have to solve. The government is taking the stringent measures to incorporate that more power plant. It's using that is various mode. It's like I say, a renewable and non-renewable source of energies. It's in quite, it is a major natural resources. It's a crude oil. Also, that's why they are using that fuel and natural gas power plant. But they also maintaining the international norms to control the pollution. So, but that India is a developing country. So we are using that coal and then fuel as a main source in the power plant. But it's creating that more pollutions, and also they are insisting to maintain that zero pollution. It means completely it's a zero carbon norms in that 2040. So according to that, then a pollution control board, then international energy agencies also taking the more effort to minimize the carbon emissions. It's then so that's why the Indian government is promoting that renewable energy sources like the solar, wind, hydro energy are achieving a goal of the zero emission to minimize the green energy also, green gases also.
So within the few words, I would like to conclude my speech. So finally, I thank the Government of India, Ministry of Education, so that took the initiation for improving the technical knowledge to all our engineering college students with interact with the industrial experts member. I assure that so then we will organize such a type of programs in future in our college. So then creating the opportunity to interact with the industrial expert members. Thank you to all.
Sir, thank you, sir. Next, introduction about Mr. Anup Rai, President, please, sir. By B. Rajesh Kumar, sir. Good morning to all. Mr. Anup Rai, 15 years experience in power plant engineering, maintenance, commissioning, reliability and assistant management, risk control of industrial gas turbines, Siemens. He completed B mechanical engineering in our college, Ananashi, Chennai. Now he is working in Agrarium Industrial Kuwait, maintenance engineering in Kuwait. Okay, sir, thank you. Next session is done to Mr. Anup Rai, sir. Thank you, sir.
Thank you so much for giving me this opportunity. So first and foremost, I would like to thank our principal sir and the veteran sir to give me this opportunity to conduct this. I'm very grateful for that, for giving me this opportunity. By the way, I will give a short introduction about myself. My name is Ani. My name is Anup. I would request everyone to just mute your mics. My name is Anup Ravi. I am the first, I passed out from MPNMJ in 2006. I'm the first batch of mechanical engineers who passed out from MPNMJ. After that, I came to Kuwait, and I've been working with power stations, various power projects, commissioning, reliability, and maintenance for this power stations. I got several trainings by GE, Siemens, and I was also been to United States for GE air engines training. So that's all about me. So I thought of sharing some knowledge which this final year students may get, some additional information so that it will be easier for them once they go to college to find a job and what kind of things they want to face. So that's all. If you allow me, I can start the presentation now. So shall we begin now? Yes, sir. All right, sir. All right. All right. So thank you so much, sir. So we will begin. So I'll be turning off my video and I will be sharing a screen. So we will go through this. See, what is the turbine? If I'm not audible, just let me know. I believe I'm audible, right? If someone can respond to my message, am I audible, right? Yes, yes. Okay, perfect, perfect. So if I'm not audible, just let me know, okay? Yes, sir. Perfect, okay. So let's begin our first chapter. So we will not be directly going to the topic. We will go through what is a turbine and what is a gas turbine, what are the applications, what are the process. So we will be going through all of these topics so that you guys can have an idea of what is a gas turbine and what are the applications of a gas turbine. Then you will get to know about the future applications. So let's see what is a turbine. Just give me one moment. Yeah, okay, fine. What is a turbine? So let's say it is a rotary mechanical device that extracts energy from a fluid flow and converts it into useful work. It means it it is a rotary mechanical device. I mean, the turbine means it is a rotary mechanical device and that extracts kinetic energy. Actually, we have two type of energy. One is kinetic energy and another one is potential energy. So turbine is a device that can extract the kinetic energy of a fluid and then converts into useful work. So that is the meaning of a turbine. So now we will see what is a gas turbine. So we have seen what is a turbine and now we will see what is a gas turbine. So as the word says gas turbine, the gas turbine is a combustion engine that utilizes natural gas or liquid fuel to make means gas turbine is utilizing natural gas or liquid fuel. I mean, we are using these fuels to burn in a combustion chamber, and with the help of this flue gas, we will try to spin a shaft and we will make mechanical energy. So that is a gas turbine. Okay, so the turbine can be anyone, anything, a mechanical rotary device that can extract kinetic energy is a turbine. The gas turbine means one has to be a combustion engine and utilizes that energy to generate kinetic energy. That's a gas turbine. I would advise to mute the mics, so that we won't have any glitch in the presentation. So now we will see what are the applications of a gas turbine. So the basic applications of gas turbines are used to fly aircraft. If you sit on an aircraft, you will see on the wings two engines on either sides. Or let's say if it is an Airbus 380, you will see four engines. So these engines are aircraft engines. I mean, these are gas turbines. Before, these engines used to be reciprocating engines, rotary engines. But since the development of gas turbines, all has been replaced because of the efficiency and the amount of thrust these gas turbines are producing. These engines have replaced by rotary engines has been replaced by the gas turbines. So gas turbines are used to fly aircrafts, and also it is used to generate electricity. How we generate electricity with gas turbine? We spin the engine and we connect a generator at the shaft. So that's how we make electricity from a gas turbine. Terrible, right? Just reply into this text so that it will be easy for me to. Yeah, okay, perfect. So now in this session, we will be going through the following topics. So what are the topics we are going to discuss? Type of turbines, components of a gas turbine, process of a gas turbine, open cycle. See, process of a gas turbine of an open cycle. And then process of a gas turbine, cogeneration plant. And then process of a gas turbine, combined cycle plant. And then I will show you a working animation of a gas turbine, open cycle as well as combined cycle. And then I will explain to you what are the auxiliary systems are required to run an gas turbine. I mean, The gas turbine, let's say it's a main unit, So to operate the gas turbine, we need several auxiliary systems. What are those auxiliary systems? I will be explaining to you later. And then we need generator. Generator means we are using the gas turbine to spin the engine. We spin it and we have to spin this generator. So what is the purpose of a generator also? We will be going through it. And there are certain other topics also I have included in the lecture so that the engineers, I mean the final year students can get a knowledge of what they are going to see after they get out of the college and go into the real world of work. So that I have included that also. Okay, so let's begin. So let's see what are the type of gas turbines. So basically there are two type of gas turbines. One is aeroderivative gas turbine. Aeroderivative means the machine, the gas turbine which are used to run an aircraft, I mean to fly an aircraft, that is a gas turbine. As I mentioned before, gas turbines are used to fly an aircraft and also it is used for industrial purpose. So among that, the first one is aeroderivative gas turbines. So aeroderivative means the turbines used in aircraft engines. So normally aeroderivative engines operate beyond 10,000 RPM. Okay, and then the commonly used aircraft engines are CFM 56, CFM 80C2, and also these kind of turbines are used for marine application. I mean to operate a ship, to run a vessel, we use gas turbines. So mostly in most of the marine engines, we use LM 2500s. So these are the type of aeroderivative gas turbines. Also, these aeroderivative gas turbine can be used to make power. How we make power with the aeroderivative gas turbines? We just connect a generator to its shaft. So normally for all aeroderivative gas turbines, there will be two shafts. One will be high speed shaft, one will be low speed shaft. So for these aeroderivative turbines, we connect a generator onto its shaft and then we make power. So those type of engines are commonly used engines are LMS 100, LM 6000, LM 2500, SGT 800. So these are the most common engines with aeroderivative turbines which are used to make power. Okay. So what are the advantages of aeroderivative gas turbines? So aeroderivative gas turbines, since it is very small, it is very cheap and faster to meet the grid demand. So it is used as a peaking station. So what is a peaking station means? Peaking station means, so we have a very big, huge industrial turbines. As our principals are told, we have coal-fired power stations in Navy, and then we have Kalpakam stations. So these are huge industrial turbines, industrial machines. So let's consider in Kuwait. So we have many industrial frame units which are operated with natural gas and gas oil. So these are very big units. Let's say one of these machine tripped. I mean during the peak of the day, the machine tripped. So there will be a glitch in the grid. I mean our frequency we should maintain 50 hertz all the time. So if any of the machine tripped, this frequency will go down. So in order to bring the frequency at a higher, at the utmost speed, we need to use a gas turbine to bring the grid demand. For that, we use peaking stations. So we use this gas turbines, these aeroderivative gas turbines, to start and synchronize to the unit in less than 20 minutes. In less than 20 minutes, we can start this type of aeroderivative gas turbines and then synchronize these turbines to the grid. So that's why it is used in peaking stations. That is the meaning of peaking station. Peaking station means to meet the peak demand, peak demand during the, one second, to meet the peak demand during the peak time. Yes. Are you saying something? Hello? I think you. Okay, okay, fine. I mean, I'm using a different screen. You're seeing the screen, which screen? I mean, you're seeing the fourth slide or the third slide? One moment. Just one moment, sir. I will just share the screen again. One moment, I will share the screen again. So you can see this type of gas turbines, this screen, right? Trailer mounted aeroderivative gas turbines. This is the screen which you are seeing it right now, right? Can anyone speak up? Hello? Yes, perfect, perfect. So these are the advantages of a picking station. So picking stations also don't require more land space because it is a very small machine, and then it also don't need much auxiliaries. I mean, auxiliaries means we have to have some kind of supporting equipments to operate a gas turbine. I mean, the gas turbine cannot be operated by its own. So we need some kind of supporting auxiliaries, supporting equipments like lube oil system, cooling water pumps, breakers. So all these are called auxiliaries, and these type of gas turbine don't require much auxiliaries. And also, to meet the peaking demand, there are trailer mounted units which you can see on your right hand side. This trailer mounted units means this all machine is equipped on a top of a trailer. So you call them, I mean, if you have a demand of power, you call them, you tell them you have a requirement of power, emergency power. They will come to you and they will mount these units, and you can have power in less than 2 months. So these are the trailer mounted units which can be installed in any place to meet the grid demand or meet your requirement. And there are also power barge. Power barge you can see on your right hand side, bottom side. These power barges are also type of gas turbines which are floating type. So you call them and you tell them that you need power. They will come to the nearest port of your country or state, and then they will connect this to the grid, and then you can make power. These are the fastest means of getting power for your peaking demands. By the way, in India, this power barges, GMR is having these kind of power barges. And then on your left hand side, you can see the jet engine. This is the overview of the jet engine which I have put for your reference. So these are the type of this is the type of aeroderivative gas turbines. So now we can go to the next slide. So now we come to the industrial gas turbines. So these type of turbines are used for industrial applications. The examples are Siemens V94.2, V94.3, G frame machines 579. So these are very huge units which can make more power, and then it is more reliable and robust units, higher power outputs, and capable of burning various fuel qualities. It means for aeroderivative gas turbines, the fuel requirements and the air requirements and the lube oil requirements are all very strict. I mean, it cannot deviate. But for this industrial gas turbines, yes, industrial gas turbines can burn various fuel qualities, and also the requirement for the purified air, water is not that strict as like aeroderivative gas turbine. So now you would understood the difference between aeroderivative gas turbine and industrial gas turbine, I believe. So now let's go to the next slide. It says about the components of a gas turbine and what is a gas turbine. So now we will see the components of a gas turbine. So as you can see, the main components of a gas turbine are axial flow compressor. You can see the intake. This is the axial flow compressor. And then comes the combustor here, what it is here. And then goes to the turbine, this one. And then goes to the exhaust. So the complete compressor, combustor, turbine and the exhaust all package, you say it as a gas turbine. So if it is an aeroderivative engine, this will be hanging under the wings of an aircraft, or if it is an industrial unit which is used to make power, it will be mounted as an integral unit and operate as a complete prime mover. Prime mover means a device can rotate something, we call it as a prime mover. So on the complete assembly is called as gas turbine. So as you can see, we have intake, we have compression, we have combustion, and we have exhaust. This is the very basic simplified view of a gas turbine. It is not simple as that it looks. It is very complicated and highly advanced. There are different kind of intake mechanism. There are different kinds of combustion mechanism, and exhaust also has to be designed based upon the gas turbine original equipment manufacturer's recommendation. So I believe you understood the components of a gas turbine, right? Someone can respond? Excuse me? I'm audible?
Yes, sir.
Perfect, perfect, perfect. One moment. Just give me one moment, please. I'm sorry for that. I will represent again. I'm sorry. So you can see the page of the process of a gas turbine, right? So now we see the process of a gas turbine. So the process is simple. I will explain to you in very simple way. The process of a gas turbine is a compressor takes fresh air inside through the exhaust or through the intake from which is from here, and then this fresh air will be compressed in this compressor where the compression is happening, and then the highly compressed air, which will be almost 15 bar, more than that 15 to less than 15 to 20 bar, it will be compressed, and then this compressed air together with the fuel, we will add fuel here, it will go to the combustion chamber where it will burn, and then the combustion will happen, and then the fuel gas will be expanded over the turbine blades. These are the turbine blades, and then it will be released to the exhaust. So let's go again. The compressor takes in fresh ambient air and compresses it to a higher temperature and pressure. So what happens when we compress? When we compress, we are reducing the area and we are increasing the we are compressing the volume. So the pressure increases. As the pressure increases, the temperature also will be increased. And once it exits out of the compressor, it will be going into the combustion chamber. While it is entering the combustion chamber, we will add fuel We will add fuel. It can be either gas, or it can be either gas oil, or it can be either naphtha, or or it can be hydrogen also, because there are hydrogen powered gas turbines are also there. So any of these fuels which can be added to the combustion chamber, and then we will burn it in the combustion chamber. And what happens once we burns it, the flue gas will occur. This flue gas will be very high hot, very high temperature. This flue gas will go into the turbine, and where it will expand over the turbine blades. That will cause the blade to spin, causing the entire rotor to spin, and then the flue gas will be going out of the exhaust. So this is the process of a gas turbine. So now we will see, I have explained about the process of a gas turbine. Now we will see the process of an open cycle gas turbine. Actually, there are two cycles. One is open cycle and another one is combined cycle. So we will see the difference between an open cycle and a combined cycle. So let's see what is an open cycle power plant first. So the process of a gas turbine is the same. There is no difference in that. Air goes inside. This compression will happen. It will go to the combustion chamber. It will be expanded over the turbine, and then the exhaust will be going out to the atmosphere. So this is an open cycle gas turbine power plant. So the air goes inside. After once the work is done, the exhaust will be taking out all the flue gases outside. And then what we will do? We will spin the shaft of a generator with this gas turbine, and we make power from this open cycle. So as you can see, open cycle, we take the air and we take the flue gas outside. That is an open cycle. Now let's see what is the combined cycle. Sorry, cogeneration plant. So actually there are three types: open cycle, combined cycle, and cogeneration. So cogeneration and combined cycle is almost similar. So let's see what is the difference between an open cycle and a cogeneration plant. Cogeneration plant is also known as combined heat and power. It's a system that simultaneously generates electrical energy and usable heat from a single primary energy source. It means in open cycle we just made power. We took the air inside, we made the combustion, and then we take out all the flue gases to the atmosphere. But in a cogeneration plant, we will take this flue gas, see this hot exhaust gas, we will be putting this hot exhaust gas into an equipment called heat recovery unit, which is boiler, heat recovery unit, HRSG. So we use this heat to convert into steam or hot water. We take this steam, we can either use the steam for heating or cooling, or we can use the steam to run a steam turbine. Okay, so we use the steam. So we, in an open cycle, what we do, we just rotate the turbine and we throw all the flue gases into the atmosphere. But in a cogeneration plant, what we will do, we will take this flue gas, put into a steam, HRSG, heat recovery steam generator, and then we convert it into steam, and we use the steam to operate a steam turbine. And also this steam can be used for heating. Let's say if you are in a very cold place, you can transport this steam to the domestic purpose to heat the building in a cold place. Or else, a long time back, I have worked on a cogeneration plant. In that plant, it was basically, the process was petroleum coke calcination industries. So once the coke get into the kiln, there will be lot of suspended particles of the petroleum coke, this petroleum coke. So what we did, we used to extract all those suspended particles of the petroleum coke, use the induced draft mechanism, and then we put in an incinerator, and we take the fuel and we used to burn it, and then we burn it, and then we put this flue gas into a steam, heat recovery generator, and then we made steam. So to burn this suspended particles of petroleum coke, we used to get the fuel from the supplier, and then in return of the fuel, we gave them the steam. Okay, so that is a cogeneration plant. So the difference is that in one side we are operating the kiln, and the other side we got the fuel from the supplier, and then we gave them steam as return, because the we cannot take out this suspended particles and throw out in the atmosphere, so we have to burn it. So we got the fuel and we returned the fuel. I mean, as a favor, we returned steam to the supplier. So we got the fuel from them and we were returning the steam to them. So those kind of plants are called cogeneration. Also, in cogeneration plants, you can use the steam to put into a steam turbine and you can make power. So that's the process of a cogeneration plant. So what are the challenges and solutions in integrating this gas turbine into cogeneration plant? We will just go through it, because as I mentioned, cogeneration plants, this steam is utilized for for building heating. So the power plants or the heat recovery generators will be installed in, let's say, kilometers away from the residential place. So you have to transport the steam, because once the steam come into contact with the atmosphere, it will try to condense it. So to preserve the heat and power generated with much thermal waste was a challenge. So the solution would be to to add more insulating materials to ensure minimal thermal loss. And the other one is that fuel challenge. Fuel challenge means, let's say, this cogeneration plants, uh, the steam is utilized by several suppliers. So we cannot stop these machines, because once we stop these machines, the customer, the consumer who is using the steam or the power, they will have a power outage. Or, I mean, if it is in a cold place, they cannot afford to have to stop the steam from coming to them, because their rooms and the buildings will get very cold. So the fuel challenge was also because we have to provide uninterrupted fuel supply, and also some gas turbines, they are shifting from fuel natural gas to hydrogen. So there was also a fuel challenges on integrating gas turbine into cogeneration plant. And then also reliability and availability. Reliability and availability means sometimes while the machines are operating, sometimes the machine can trip and it can stop, it can make an outage. So in those cases, what happens, the entire of the process will be stopped and it will go completely interrupted. So we have to operate in an uninterrupted stage. So for that, reliability and availability is also a challenge for integrating gas turbine into cogeneration plant. So now we will see the process of a combined cycle power plant. So a combined cycle power plant is almost similar to a cogeneration plant, but the difference is that the steam produced by the steam generator will be completely entirely used to operate a steam turbine. The steam will not be going to any other sources or any other consumers to heat the building or anything. It will be completely, the steam will be dedicated for to operate the steam turbine. So that's the process of a combined cycle power plant. So it is very simple. The combined cycle process is very simple. You take the flue gas from the gas turbine, you put it into the heat recovery steam generator, which is HRSG. You make the steam, and this steam you put into the steam turbine, and then we make power from the steam turbine. So the efficiency of the combined cycle power plant is almost greater than 60%, whereas the efficiency of a gas turbine is almost 40%. So by putting these combined cycle plants and cogeneration plants, you can increase the efficiency of the complete station. So that's the difference between open cycle, cogeneration plant, and combined cycle power plant. Do you have any questions in any of these topics? I believe I have covered it. If you have any questions, let me know now. I believe we are okay. Now we will proceed to the next slide. Okay. We can proceed to the next slide. Anyone have any questions? So I am proceeding to the next slide. One moment. So these are the, now we will see the cutaway of a gas turbine. It means what are the internal components of a gas turbine. I mean, there is lot more than this. I have put out very few pictures. So as you can see, this is the compressor bearing. Actually, most industrial gas turbines will have two bearings, one on the compressor side, another on the turbine side. So this is the first bearing, the compressor bearing. Normally for all type of industrial gas turbines, they will be having this journal bearings, and aero engines, all of them will be having ball bearings. So for industrial gas turbines, all the bearings will be journal bearings. You can look up the difference between journal bearings and ball bearings. Ball bearings, so this industrial units use journal bearings, and you can see this compressor bearing inner housing, and then this is called the casing. And what you see inside all these are the compressor blades. If you look at here, this compressor is known as axial flow compressor. So all gas turbines will have axial flow compressor. And once this air gets in and compresses under here, it will enter to the combustion chamber. As you can see, this is a combustion chamber. This is one type of combustion chamber. This is used, the method what is used in this combustion chamber is tiles. I mean, basically it is ceramic tiles which can accommodate the temperature of more than 3000 degree F. And there are different type of combustion chambers. Some combustion chambers are called can type combustion chamber. This is singular annular chamber combustion chamber, and these blades are called the turbine blades. So this is the compressor, axial flow compressor. This is the combustion chamber. As I told, there are two type of combustion chambers. One is single annular combustion chamber, and the other types will be can type compressors, and this will be the turbine blades. Okay. Now we will see a short video of how a gas turbine works. A simple video how an open cycle gas turbine works. As you can see, the cold air goes inside. Then we will add the fuel here. The combustion happens in the combustion chamber, and the flue gas will be expanding over the turbine blades, and the flue gas will be going out to the atmosphere. So that's the process of a gas turbine. I will play it again once again for you. Okay, that's the process of a working principle, working of a gas turbine. Now we will see, I have explained to you about open cycle and combined cycle. So we will see the difference, how, I mean, a picture can say 100 words. So I will play a video for you so that you will understand better. So this is the difference between an open cycle versus combined cycle. So you can see this video. Now the machine is operating on combined cycle mode. You see the flue gas is coming and it is going out. And now the flue gas is escaping to the atmosphere through this stack. So now the machine is operating on what? Open cycle. See this one? Now the machine is now opened again. The opening mechanism, this entire mechanism is known as diverted damper. So that if there is an open cycle, there won't be any diverted damper. So once we install this HRSG, which is heat recovery steam generator, we will be installing a device called diverted damper. With the help of a diverted damper, we can operate the gas turbine in either open cycle or in combined cycle. You see this? Now we open the damper, all the flue gas will be going to the HRSG and we are making steam. And this steam can be used where it can be used either to create, spin a steam turbine, or also we can use the steam for utility purpose in a cogeneration plant. And now we have closed the damper. Now the machine is operating on open cycle. So that's the difference between an open cycle and a combined cycle. I believe it is clear for you guys what is the difference between an open cycle and combined cycle. Perfect. So now we will go to the next slide. So as I have told, gas turbine cannot be operated by itself. So it got certain auxiliary systems to operate the gas turbine or a steam turbine. It got to have some kind of auxiliary system. So first auxiliary system, which is very important for a gas turbine or steam turbine, is lube oil system. So what is a lube oil system? So lube oil system is same like our car. We start the engine creates friction, and that friction has to be taken away. We have to reduce the heat. So we use oil. Same purpose of the oil here. We will have an oil tank, and we will be having pumps, which is called auxiliary oil pump, and then emergency oil pump. So these pumps will be pumping this oil into the cooler, and then again it goes to oil filter, and then filtered oil will be going through this steam turbine, generator, gas turbine, everywhere. So the main important factor what we have to consider is the oil has to be as per the industrial standard, and then whatever oil we are putting into the bearing has to be filtered properly before we put this oil into the bearings. For car also we used to do service. We change the oil and filter. We change the filter and we filter the oil before we put into the machine, right? The same, we have to use an oil filter to purify the oil to put into the bearings, or else what will happen? You can have a damage on the bearings. So normally in industrial gas turbines, we use 25 micron rating of filter, and for aero machines, we use filtration methods less than 5 microns. So you see the difference, how important oil filter for aero engines and what is the micron rating for a filter for an industrial gas turbine. So for aero engines, the standards are very strict. For industrial gas turbine, the standards are little bit liberal, because we are using it for industrial purpose. Even though aeroderivative engines are used for industrial purpose, the standard of aeroderivative will remain as aircraft standard. So we have to maintain the aircraft standard for aero engines. So this is how a structure of lube oil system will look. You can see this one here. We have lube oil pumps. We have lift oil pumps. Lift oil pumps, I forgot to tell you, lift oil pump means the industrial gas turbines are very huge and it is very heavy. So to spin the shaft, we need to lift the shaft. We use these special pumps called lift oil pumps. These lift oil pumps will be generating a pressure of more than 160 bar, which is a lot of pressure. With this pressure, we lift the shaft. We lift the entire gas turbine and the entire generator shaft to 1 millimeter, less than 1 millimeter. 1 millimeter, right? I believe all of them knows 1 millimeter. So we lift the shaft less than 1 millimeter. So that is the purpose of this lift oil pumps. And then we have this lube oil pumps here. Lube oil pump's purpose is to provide uninterrupted supply of lube oil to the bearings. As you can see, we have two lube oil pumps. Two lube oil pumps are for one will be in operation and another one will be for standby. So in a gas turbine, all equipments will have a redundant equipment. Redundant means if one fails, next one has to take over. So if you look at any gas turbines, even if it is industrial or aero engines, there will be redundancy. Redundancy means if one fails, the next one has to take over. Aero engines will have more redundancy because it is made for aircraft standard. So it will have always have more redundancy. But for industrial turbine, the redundancy will be there, but it will not be as strict as for an aero engine. So those are, I mean, a typical lube oil system skid will be looking like this. And next we will see the air intake system of a gas turbine. What is an air intake system? Air intake means, as you have seen this here, this air the air what is taken into the gas turbine is filtered air. I mean, we cannot put any kind of air into the gas turbine. All the air what goes inside, all the fuel what goes inside, everything has to be filtered. I mean, there is no way that we can just put atmospheric air into the gas turbine. If you put atmospheric air directly to the gas turbine, the your maintenance frequency will be increased. You will have a question now, why the jet engines don't have air filter inside? Because we cannot provide filtration method to the jet engines, so it will directly take the ambient air inside. Once the aircraft flies to a certain level, it will be very clean air will be there. So we don't need, I mean, there is no possible way that we can install any kind of filters for jet engines, because it will the flying time, because it will be very less timing, I mean, the aircraft will be operating, the jet engines for an aircraft will be operating for very few hours, few minutes on the ground. Remaining time, all the flying, I mean, all the engines will be operating while it is flying. So we will be getting clear air from the atmosphere. So, and also it is not possible to provide filters for an jet engines. So for industrial turbines or industrial aero engines, we should have a system called air filtration system. So in air filtration system, what it will do, it will take the fresh air into the filter house. This entire system is called filter house. It will be taking air into this, and there will be certain different layers of filtrations. The first one, as you can see, is called pre-filters, and then we have final filters. And in some gas turbines, we will have something called evap media. So as you can see, there are three line of defense before the air enters into the gas turbine. Okay, so it has to, the gas turbine, whatever fuel or whatever air we are putting into the gas turbine has to be purified, has to be filtered to the OEM standard. Normally, the air will be going inside will be less than 1 micron filtration will be there. 1 micron means our human hair is almost 1200 microns. So you can imagine how much is a 1 micron. So 1 micron filtration is required for most of the gas turbines. This is to protect the blades. I mean, this is to protect the blades of the gas turbine, combustion chamber of the gas turbine. So this filtration, air intake filtration is very important. So this is the overview of the gas turbine inlet air filter system. And now we will go to the fuel gas system. So what are the things which goes into a gas turbine? Air, fuel, and sometimes water also will be used. But let's consider only air, fuel, and oil here. So as you can see, fuel system of a gas turbine. So this fuel gas system also has to be filtered before we put into the engine. So the filtration is also less than 1 microns. So now let's see in detail about the fuel system of a gas turbine. The gas turbine's primary fuel is natural gas. The name says gas turbine. So gas is the primary fuel. But what you will do if you don't have gas? We have to have a secondary fuel. So most of the gas turbines are designed to operate on an alternate fuel. So what is alternate fuel? The alternate fuel is liquid fuel, which is gas oil. Gas oil is nothing but diesel. We use industrial term of diesel as gas oil. Normally, gas oil, diesel with low sulfur is known as gas oil. So if any industry, you say we are operating on gas oil, you should understand that machine is operating on low sulfur diesel. So gas oil, and there is one more fuel which is called naphtha. So these are the liquid fuels that can use to operate a gas turbine. So as I told, gas turbine primary fuel is natural gas. But if you don't have natural gas, what we will do? We use liquid fuel, which is gas oil and naphtha. As per the latest advancement in the gas turbines technology, now some places they are using biogas, synthetic gas. They are using hydrogen. All these new alternate methods are also being implemented right now. So these are the latest advancement of fuel types in a gas turbine. So now let's look at what is a natural gas system means. So if you say about a gas turbine, so gas turbine as I had mentioned, primary fuel is natural gas. So what is a natural gas? So the major component of a natural gas is CH4, which is methane. So you may have heard about the alkanes of a natural gas system, which is methane, ethane, propane, pentane, butane. So all these things are the hydrocarbons of a natural gas system. So to operate a gas turbine, we need methane. We need methane. CH4 should be the main component of the natural gas. If any other component is higher than higher than methane, then it can cause issues to the gas turbine internal components. So always keep in mind that we need high methane component of natural gas to burn in a gas turbine. So this natural gas is classified into two types. What are those types? One is sweet gas and another one is sour gas. What is sweet gas means? All natural gas, as you know, these are all fossil fuels. It has been extracted from the under the earth. So, can you please switch off the mic? Can you please switch off the mic? Thank you. So, as I said, we have two type of gas. One is sweet gas, and another one is a sour gas. Sweet gas means the gas which is less hydrogen sulfide. So, if the gas is full of hydrogen sulfide, we call it as sour gas. Sour gas, we cannot burn it on the gas turbine because sour gas is highly corrosive in nature. So, always keep in mind to burn fuel in a gas turbine, we need sweet gas. So we cannot just simply take the natural gas and put it into the gas turbine. So we have to compress it. So the gas is compressed with the natural gas boosters. So natural gas boosters will increase the pressure and temperature to the OEM specifications. OEM means original equipment manufacturer. So it could be Siemens, it could be GE, Mitsubishi, so whatever. Let's say consider our car, So in our car or in our bike, so the company will say us, okay, you have to use this kind of petrol, you have to use this kind of lube oil, this kind of engine oil. So we have to maintain the specifications. So that's the manufacturer is known as OEM. Let's say your bike is a Honda, or let's say your bike is a Bajaj. So Bajaj is the OEM of that motorbike. So like that, OEM means original equipment manufacturer. This is a very important term for you guys because once you start working in an industry, you will not say, manufacturer, you will say OEM. OEM means original equipment manufacturer. So this original equipment manufacturer will specify, let's say you are operating a Siemens gas turbine. So the Siemens will say, okay, I need for my gas turbine, I need this much pressure and I need this much temperature. Why? Because this gas turbine is designed for specific design parameters. in order to maintain that design parameters, they need the fuel to be at their specification. So we have to increase the temperature and pressure. So gas compressor, this natural gas boosters will help to increase the pressure and temperature. We will take the gas and we will compress it. Once it compresses, what will happen? The molecules will get energized and it will release energy as heat. So once we compress the natural gas, the pressure will be increased as well as the temperature also will be increased. So then we will supply this natural gas for combustion. Now let's look at the fuel gas system, fuel oil system. Fuel oil system is, as I told, it could be gas oil or naphtha. This is a secondary fuel. This is not a primary fuel. So if you use gas oil or naphtha for burning for spinning the turbine, your maintenance hours for the gas turbine will go for 1.5 times, because gas turbine, as I told, it is a primary fuel is natural gas. If you are using liquid fuel, it will operate, but what happens? The operating hours the maintenance counter for the machine will increase. Now let's see about the gas compressors. Gas compressor is a auxiliary system for the gas turbine. As you can see, most of the gas power plants, we use two types of gas compressors. One is centrifugal type, and another one is reciprocating type. As you can see, this is a centrifugal type and this is a reciprocating type. In centrifugal type, gas goes inside and it will be, compressed with the help of an impeller. Okay, it will be compressed by means of an impeller, and then pressure will be increased. You can see on your right hand side is a reciprocating engines. As you can see, this piston will go back and forth and it will be compressing the gas to the OEM requirements. So this is about the gas compression system. So as I told, in an industry, in a gas turbine, typical gas turbine power station will be using two types of gas compression system. One would be centrifugal type, and another one would be reciprocating type. Now let's see the equipments of a fuel gas system. Now in the last slide we have seen the type of gas compressors. Now we will see the type of liquid fuel system which is used in a power plant. So these are the type of fuel oil systems. The first one is known as gas oil centrifuge. Gas oil centrifuge is a device that will help to clean the fuel. I mean, basically this centrifuge will take the oil and it will wash with the water. So water will be mixed together in this equipment and we will literally wash the liquid fuel. I mean, if we take the fuel, it's like basically take the fuel, add water, mix it properly, and then take out all the impurities from the gas oil and take out the fresh gas oil from the machine. So that's the purpose of this gas oil centrifuge. This is one of the very important equipment of the power station because this will help to maintain the purity of the gas oil system. And the next one should be, pumps. This is a centrifugal pump. The second one is a centrifugal pump. These are normally used to, pump the fuel. And the last one is a centrifugal pump also. But this is a multi-stage pump because for gas turbine, before we put the fuel into the gas turbine, we need the pressure to be like, let's say, more than 100 bar. So we use these kind of multi-stage pumps to boost the pressure before we put into the gas turbine. Okay, so these are the type of equipments which is used in liquid fuel system. Liquid fuel system means it could be gas oil or naphtha system. Once again, gas turbine can operate on natural gas and the primary fuel is natural gas and it can be operated on fuel gas also, fuel oil also. So for gas, we use two type of compression, centrifugal type and reciprocating type. And then for liquid fuel system, we use these equipments to to clean the fuel and to supply the fuel. Now we will see what are the type of heat exchangers used in a power plant. So why do we need a heat exchanger? As I told, heat exchange, I mean, when we operate any equipment, there will be a lot of heat will be produced. So in order to take away that heat, we need plate heat exchangers. We need heat exchangers to take away all the heat. So we use heat exchangers. So there are basically two types of heat exchangers is used in a power station. One is called as plate heat exchangers, and another one is a shell and tube heat exchangers. As you can see, the oil goes inside, and then the cooling media will also go inside together. As you can see from the bottom side, the blue side is the this water, and the red will be the oil. So one after another, it will come into contact, and that's how the heat will be transferred. You can see the shell and tube working animation also here. You can see how the oil goes inside and how it will get cooled off. So these are the type of heat exchangers used in a power station. So now we have, because when we operate a gas turbine, the bearings, all the things will get hot. So to cool the bearings, we use oil, but that oil has to get cooled, right? So for that purpose, we use this heat exchangers. Now we will come to the conservation of energy. So now we have covered all the auxiliaries of a gas turbine. Now we will see how the power is transferred. So we have a basic law, conservation of energy. As I told, we are using natural gas, which is chemical energy. We put it in the combustion chamber, we burn it, and we spin a shaft. So we are converting this chemical energy into mechanical energy, and then this mechanical energy is going into the generator, and we are spinning the shaft. And by spinning the shaft, we are making electrical energy. So we are not creating energy; we are converting the energy into one form into another. Okay. As the law of conservation of energy says, energy cannot be created or destroyed, although it can be changed from one form to another. So let's say we have this chemical energy going into the turbine. We may turn this chemical energy into mechanical energy, and that mechanical energy we are turning back into electrical energy. Now we go to the generator because we have spin the turbine. Now we need the purpose of spinning the turbine is not to just spin, right? We have to make power. So to make power, we use generator. So this is a typical generator, industrial generator, which is used, which is very huge. So this generator spins at 3000 RPM because to make 50 hertz, we need to spin the generator at 3000 RPM. Some places, the frequency is 60 hertz. To operate, to make 60 hertz, we need the generator to be spinning at 3600 RPM. Okay, so in India, we spin the generator at 3000 RPM in order to get 50 hertz. So this is a typical generator. This generator also, as I told, there will be heat generator inside the generator once the machine operates. So there are generators filled with hydrogen for cooling, and some generators are air-cooled generators. So this, as you can see, the generator also have bearings. These bearings are also cooled by the lube oil of the gas turbine. This is about the generator. Now we see BOP. So as I told, gas turbine cannot be operated by itself. It needs certain auxiliary equipment to support the operation of the gas turbine. Those equipments are known as BOP, balance of plant. Once you go to the industry, they will say in BOP, you have to check this. So BOP, if they say BOP, you have to understand what is the BOP means. BOP means balance of plant. So what are the systems that is required, necessary to support the operation of a gas turbine? There is water system. The water is also, there are three types of water. One is service water, another one is genuine water, the third one is potable water. So, and then we have air system. Air system is also two types because there will be several valves, pneumatic valves, which will operate on air, so that we need instrument air in a gas turbine power station. So there are two type of air. One is instrument air and another one is known as service air. Instrument air is nothing but the air with no moisture inside because we cannot put moisture into the instruments. If you put moisture into the instruments will get damaged. So we need to have air free from all the moistures. So that kind of air is known as instrument air. And then we also need an air called service air. Service air is nothing but the air used for utility purpose. Utility purpose means cleaning. Okay, so we have two type of fires, and then we have fuel system, which is gas and oil, and then we have chemical dosing system, closed cooling and open water system. So these are the systems used in a balance of plant. These are the systems of a balance of a plant. Now go to the next slide. How to select a station for a power station. How to site selection of a power station. How the site can be selected for a power plant. As you can see, when the gas turbine is operating, it will create loud noise and it will also cause pollution. So this typically gas turbines has to be located somewhere outside of residential area because of its noisy operation. And also there is a lot of weight, for the generator, for the turbine, there will be a lot of equipment. So the land which you will be selecting has to accommodate that kind of vibration. And then fuel also has to be available at a very cheap cost. And also it has to be near to a water source because it has to be near to a river or sea because we need water to operate the power station. So these are the basic requirement of a site selection of a power station. And then now we see how we can start a gas turbine. How we can start a gas turbine. Second. Excuse me, you can see my screen, right? Can someone reply? Not visible. Not visible. Okay, okay. Just one moment. Can you see now? Perfect, perfect. So now we see how the gas turbine a power plant starting sequence. I mean, how we can start the system. So before everything, before we start the gas turbine, we have to start the BOP systems, which is the balance of plant. Yes. Can someone stop the mic? Can you mute yourself? Okay. So before we start a station, we have to the BOP system has to be operating. The BOP system has to be operating. It means all the equipments has to be operating, and then all the operating parameters of the BOP. Can you mute yourself? Okay. So all the operating parameters of the BOP system should be healthy, and for industrial gas turbines, the gas turbine would be on a turning gear operation. All the required gas turbine options should be in auto operation because everything has to be in auto. Excuse me, can you tell him to please mute himself? Oh, perfect. Thank you. And then we start the gas turbine. We check there is no abnormal alarms, and then we achieve full speed no load. Full speed no load means we achieve 3000 RPM, and then we give the command to synchronize to the grid. And once we synchronize to the grid, we increase the load as per the demand. So now we see what are the types used in a power plant. So these are the typical type of pumps which is used in a power plant. This is split casing. The first one is a split casing pump. This is a centrifugal pump, vertical pump, and then this one is a multi-stage pump. And now let's see what are the type of valves used in a power plant. So these are the common type of valves which is used in a power plant. This is a typical ball valve, which is a top entry ball valve. This is a three-piece ball valve, and these are called floating ball valve and Tonian mount ball valves. And this would be a gate valve. The gate valves are type of gate valves are bed step, parallel slide, pressure seal bonnet, rising stem. So these are the typical type of gate valves which is used in a power stations. All pipings, valves, and related accessories has to be based on the design conditions. It means that you cannot just simply select any equipments and mount it anywhere. You have to check the specifications. You have to check the pressure rating before you put everything before you install it. And therefore, for a normal gas turbine, the pressure class will be maximum until 600 class, and the most of the materials will be used of carbon steel and stainless steel. But for steam generator and steam generation applications, the classes will be more. I mean, it will be 800, 1200, 1800, 2500. And the material of construction also will be high class carbon steel, super duplex steel, and alloys. So it is very important to select a material before you install it. And these are the type of valves called diaphragm valves. Diaphragm valves are also a type of valves which is basically used for the water system, because water can make corrosion. So if you put the carbon steel valves in water system, it will get corroded. So for that we use diaphragm valves, which is completely rubber lined. And this is a type of valve which is called as a needle valve. Needle valve is also used for throttling purpose. This is also one of those valves you will be seeing in an industry. I mean, all these valves are not only used in power stations, it is also used in several other locations also, other industries also, gas stations, refineries, chemical plants. You will come across all these kind of valves, So this is not typically limited to gas turbine plants. These are common valves which is used everywhere. Either it could be ball valve or it could be gate valve, diaphragm valves. All these valves are typically used everywhere. Now we will see the very important topic, which is the type of drawings used in an industry. So if you look up to an industry, whether it could be gas plant, refinery, or power stations, you could literally see drawings like this, which will be completely different drawings from what we have learned in the engineering college. So these drawings will be completely different. So this type of drawings are called general arrangement drawings. If you see a GA drawings, you can see how the equipments are located and what are the orientations of this equipments. The GA drawings are used to see the orientation of the equipments. And the other type of drawings which you will be looking at it, right? Civil drawings. Civil drawings is also very important drawings for mechanical engineers. Why? Because if you are going as a construction engineer, the construction engineers has to give clearance for civil before they pour concrete or before they install anything. Let's say civil will make the structure and you have to install an equipment. Let's say you have to install a pump on the civil support. So the civil engineer will be calling a mechanical engineer and he will tell the mechanical engineer, okay, give me the confirmation to pour the concrete. So the mechanical engineer has to look at the civil drawing, look at the general arrangement drawing, look at the orientation and tell that, okay, you can pour concrete. Once you pour the concrete, there is no going back because the equipment, because you will be going to install an equipment over there. So it is very important for the mechanical engineer to know, to read, how to read a civil drawing. If the engineer is going for a construction phase. So if the mechanical engineer is going to be a construction and an erection field, civil engineering is a prime important drawing because without the clearance of a mechanical engineer, civil engineer will not pour concrete for the final assembly. So civil drawing is also important for a mechanical engineer. And the next type of drawing which you will be facing in an industry is called hydraulic circuit drawing. Hydraulic circuit drawing means these drawings are basically show you how the solenoids, how the circuit of a solenoid will be working, because this is also important for a mechanical engineer to know, because if one of your equipment is not functioning properly, you have to do a troubleshooting, because if you are a responsible engineer of that facility, you will be given, you have to find out the hydraulic circuit drawing and you have to shoot why the system is not working. So hydraulic circuit drawing is also an important drawing for mechanical engineer. And the next drawing will be process flow diagram. Process flow diagram means for if the mechanical engineer is going as a operation engineer, he should know the operation. I mean how the plant is operating. So he should be knowing how the process goes. So this is a typical what I have provided here is a typical process flow diagram for a gas turbine power station or a HRSG for steam turbine power station. So this will be the flow diagram. By looking at the flow diagram, he should understand how the fluid is moving from one place to another. Okay, whether it is gas, whether it is water, or whether it is steam. So how the process flows, how the process flows. The process flow can be identified by using a process flow diagram. So this process flow diagram is also very important for a mechanical engineer. And then comes the P&AD. P&AD is drawing known as a mechanical flow diagram. It's called process and instrument diagram. This is one of the important, very important drawing which a mechanical engineer will come across. By looking at it, you will know the flow, you will know the pressure points, you will know the temperature points. All the process can be read from this P&AD. So P&AD is also one of the very important drawing which mechanical engineers should be the engineers will be facing once they go to an industry. As you can see on your right hand side, these are the symbols which will be used in P&AD. So these symbols are very important. You can see all kind of equipment symbols. These symbols will be used here on your left hand side drawing. So P&AD is also very important drawing for a mechanical engineer. Now we will see what is the future advancement of power sector. We need power for our day-to-day life, right? Because we cannot even imagine a day without a power, because you cannot afford, because everything works on power now. So as you can see, the majority of the power produced is from fossil fuels. Fossil fuel means coal, natural gas, gas oil, naphtha. These are the majority of the power we produce from the fossil fuels. So what will be the future advancement? I mean, we cannot just simply burning the fossil fuels because it's going to affect the carbon emission. So a lot of environmental issues, even though we take much steps ahead to stop the emission, to control the emissions, if it is fossil fuels, in a gas turbine plants, we will be installing SEMS equipment. SEMS means continuous emission monitoring system, which is used to measure NOx, SOx, to control the emission. So these NOx machines, this SEMS will be installed to know how much of NOx and SOx, sulfur oxide we are putting out the environment. So now government, the people have put strict measures, and the OEM also is trying their best to reduce the NOx emissions. So what will be the future advancement to reduce all these things? As you can see from this source, the coal is always the king. Coal makes 37 percentage in the total production of this power production among the world, and then comes the natural gas, which contributes to 24 percentage, and then comes the hydro. So as you can see, coal and natural gas are the main things, and this power also can be generated from wind, solar, tidal, and hydro, but these are not sufficient sources for our requirements. Even though it is renewable source, it has its own disadvantages. So there are the few technologies that can meet the future. The future development will be like instead of coal, we can use biomass. Biomass. This is a new advancement. Geothermal source is another source, and then we can use nuclear plants, and then installation of captive solar plants. Captive power plants means let's say in our college, let's assume in our home, we can install a small solar panels and we can make our own power. So that's kind of captive stations. What will it will do? We are making our own power from the solar station, so it will reduce the demand on the grid, and then the main grid power stations can reduce their power output. Thereby, we can reduce the carbon emission. So installation of captive solar plants in Cochin, in my place in Cochin, our airport is completely operated with solar energy. It is a 100% solar captive stations installed there. And then the next method is like optimization of exhaust gas treatment of diesel and gas engines. That is also a future advancement. And then alternate fuels can be used like biodiesel for the diesel engine. And then for gas turbines, we can use hydrogen, biogas, and synthetic natural gas can be used as a future advancement. So these are the future advancement in the gas turbine power stations. So being said, my session is done. So I believe you guys understood, and I'm very happy to share my knowledge. Thank you so much. If you have any questions, I have provided my WhatsApp number. You can ask me any questions, related to the work, and I'll be more than happy to help you guys. Because when I came out of college and joined an industry, I came to know that most of the things what I learned, the drawings was completely different for me. So I thought I would, educate the new graduates so that it will be much more easier for them to understand what's happening outside in the real world. Okay. There is one question from Sujit. Natural gas, natural gas, normally days you can use this gas. Yes, the gas can leak from the gas turbine. So in a gas turbine package, we have installed gas detectors, flame detectors, and the complete gas turbine package is protected with carbon dioxide or fire extinguisher systems, and the complete package is well protected. You cannot enter into a gas turbine thermal enclosure while the machine is operating, because in case of a leak, the gas detector will pick up and it will trip the machine and it will stop the complete gas network. So in a power stations, we call it as a fire matrix. The fire matrix will decide. If you detect any fire or if you detect any gas, there will be redundant sensors. This will act and it will stop. It will send a signal to the gas valve to completely stop the machine. It will trip the machine, and if there is a fire incident, what will happen? The machine will go for trip, the gas valve will be closed, and there will be CO2, and like inert gas will be there, CO2 and argon will be there. These argons will be released into the chamber, and it will extinguish all the fires. So gas turbine is well protected. Fire system is a prime important factor for a gas turbine station. Not for a gas turbine station, any station. Fire extinguishing, firefighting, and fire detection system is a very important system. With this system, all the equipments will be well protected. You heard, but I'm not hear your voice, please. அது யாரம்மா போன வச்சிருக்காங்க பாரு. அது யாரு போன வச்சிருக்காங்க? நீங்க அக்கா பையன். அக்கா பையனா அது? இந்த வரைக்கும் பொண்ணு நினைச்சிட்டு இருக்காரு. Okay, so if you have any questions, any doubts, you can just text me. WhatsApp me in this number. You have any questions? ஒரே பொருளுக்கு பட்டா முடி போடுறது வச்சு கேக்குறாங்க. Yeah.
And compared to other things like turbines.
For gas turbine power stations, the efficiency will range from 40 to 45%. To increase the efficiency of a gas turbine station, what we will do, we will put a steam turbine on it. So what we can do, we can increase the efficiency of the motor station nearly 60 to 70. Sir, done, sir. Yes, sir, it's done. It's done.
I thank you all so much. I thank our respected principal, Dr. M. Ramesh sir, who good governance to has been great inspiration to everyone. I thank you, sir. I thank our college Jolly sir, Thiru M.B. Devismani sir, for being with us in all aspects. I thank you, sir. An immense pleasure to thank Dr. K.P. Vetrivel sir, our mechanical department HOD and the coordinator for this session, who have taken a large amount of steps to take a Mac function as grand success. I thank you, sir. I extend my heartfelt thanks to all teaching and non-teaching members and our department students, college students. Once again, I thank you all. Thank you. Hello.